decimal value which is equal to 1. Why equal to 1? Because when in your binary form, if 00001, right? What is the decimal value you get? You get 1, right? Okay. Or if you want to make RB0, RB1, and RB2 as input, right? If you want to make RB0, RB1, and RB2 as input, so in binary form it is 0B 0000011. Okay, so you have 3 digital inputs. Okay, if you don't like to use binary form, you can make it in decimal form. So what is 0001 means? So you have 3 triple 1, right? So in triple one of binary, the decimal value is 7. So you can, if you don't like to use digital form, this is a binary form, you can use decimal value of 7. It is the same, but to use decimal form is very difficult for us to read. Okay, so we prefer to put back binary form, because from binary form is clearly for us to see that pin 0, pin 1, and pin 2 are input. Okay, then pin 3, pin 4, pin 5, pin 6 until pin 7 are output. Okay, easy to read. Okay, so I'm making pin 0 as input, the rest are all output. Okay, using this line of code, thrice b equal to 0b, then the input output setting. Okay, 0 means output, 1 means input. Okay, 0 means in output, 1 means input. Okay, after that, then we write our WA1. Okay, then we write our WA1. So our WA1 is our WA1 for RB0. We have to look back here. For our example here, I'm making RB0 as active high configuration. Okay, I'm making RB0 as this active high configuration. So RB0 here means SW0, right? So if SW0 is pressed, okay, if SW0 is pressed, then what I want the LED 0 to do, I want LED 0 to be turned on. Okay, else if it is not pressed, LED 0 is equal to 0, so LED 0 will be off. Okay. Okay, so here I put a human language. I write if SW0 is pressed. So SW0 is pressed here means what? Here means how do the microcontroller know SW0 is pressed? It is based on the current flow, right? Because you see, the switch, one side of the switch is connected to positive V to 5 volt of power supply. So when this switch is closed, the power supply will flow into RB0. So that means when the switch is not pressed, RB0 will be no current go in. Okay, will be no current go in. Okay, if there is no current if there is no current flow into RB0, okay, the status of RB0 is equal to 0, is low. Okay, so when the switch is pressed, when the switch is active, right, the current will flow into RB0. So RB0 will be high. That's why it has a name called active high. Okay, when the button is active, RB0 is high. That means when the push button is pressed, RB0 is high. So that means our controller will know that when the button is pressed. The controller will know the button is pressed when RB0 is high, right? So you have to write the language that the controller understands. Okay, when RB0 is equal to high, which is equal to 1, that means switch 0 is pressed. Okay, if switch 0 is pressed, then I turn on. If not, then I turn off. Okay, then we compile the program. Okay, build successful. Okay, then this is DMR2 week 3 P1. Okay, with DMR2 week 3 P1. So I need to load DMR2 week 3 P1, this which is this one, distribution, default, production. Okay, this hex file. Okay, then I need to pull in one push button, and then I need to pull in one LED bars. Okay, just how I make in my setting here, I make RB0 as switch 0, right? So here I need to pin select, okay, port B, pin 0. Then this is RB7 as LED 0, RB7 as LED 0. So this is port B, pin 7. Okay, port B, pin 7, port B, pin 0. Okay, I need to make it active high. Okay, I need to make it active high. So in your push button here, under the type, so you need to change it to when pressed, right, the status is equal to 1. Okay, when pressed, the status is equal to 1. So you are simulate active high configuration. Okay, if you choose this, you are simulate active high configuration. So then we run. So when I press, I get my LED turn on. When I release, LED turn off. Press, LED turn on. Release, LED turn off. So, so this is how we make how we make a general purpose I/O GPIO and input. Okay, how we make a GPIO and output. Okay, how we declare a GPIO, and then how we use GPIO in our programming. Okay, so you need to know the key is what? The key is you don't know whether you don't know. You will not know. Okay, I will say you will not know when is 0 or when is 1. You don't know whether 0 is pressed or you don't know whether 1 is pressed until you know, okay, what is the hardware wiring or hardware configuration is. Okay, in other words, if you design this project, you need to know what kind of wiring that you are using. If you know what kind of if you know whether it is active high or active low, right, then only you can write the programming. So wiring first, then only programming. Okay, you need to know how you do the wiring, then only you can do the programming. Otherwise, you don't know whether 0 is pressed or 1 is pressed. Okay, so for this first example, I am testing active high configuration. Okay, that is when the switch is equal to 1, I know that the switch is pressed. So when the switch is pressed, I want to turn on LED 0. Okay, a very simple example. So far, so good. Everyone okay?
Yes, sir.
Okay, Yiheng, okay? Try Yiheng.
I'm okay with the code, but I can't run the thingy at the real picture simulator.
You cannot do real pic simulator.
Yeah. The output, the LED will not show. Yeah.
The LED is forever off or what? In your case.
Yeah, forever off. Yeah.
So never turn on.
Yeah.
Okay, if okay, you try this way, you try this way. Are you having WA1?
Yeah.
Okay, so now you comment your WA1. You comment you use comment all, okay, slash then asterisk then slash, right? You comment all the WA1, right? Okay, then your tries B, you make it all, you try, okay, now you try first, your tries B, you make it all 0, make it all output. It means 0B, then all the pins are equal to 0. Okay, then next, you type port B equal to 0B, then you put 8 times of 1.
B equals to
0B, then 8 times of 1.
yeah.
Okay, then you compile.
F11.
After you compile, then you're in the real pick simulator, all your pins, right? All your pins, you make it LED. Okay, B6, B5, okay, B4. Okay, I just show 4 only. Okay, then you then you load the hex file again. Then you should see all the LED turn on because your program is very simple. You turn on all the port LED. You turn on all port Bs. So can you see your LED turn on?
Open. Give me a second.
Yeah. You try go compile and then run.
Yeah,
Then
it's on.
It can turn on, right?
Yeah.
Okay, then no problem with your real pick simulators. Then you go back to your program.
We open the Wawa.
Yeah, port B equal to 0B111, right? You command, then you open up the WAW1 again. Okay, open up the WAW1 again. After that, make sure your tries B, the setting, the last one, the bit 0 is you change back to 1.
Yeah.
Okay, you change back to 1. Okay, then you try to compile and run again. You try to compile. Okay, and then you go back to your program, then you load the hex file again. Okay, then you run, then now you press your push button. Can your B7 turn on?
E7.
Sorry?
Wait,
Ah,
E7.
can turn on B7 or not?
Oh, I think I select
Wrong port.
P. Yeah, wrong port. Yeah.
Okay.
Can already.
Okay.
Yeah.
Okay.
Okay, thank you, sir.
All right. Others, okay? Desmond, okay or not? Okay. Ighao?
Yes, sir.
Okay. Then we go to the next. Wait.
I wait. Sir, I don't know why my coding there that shows the tries B is not highlighted. I don't know what's the problem with the program. I think it's the coding.
You share your screen?
Wait, I'm using it now.
So, Kaseng, are you okay? Okay, wait, let me read your program. Okay, your LED, you see your else there, LED 0, you put LED equal to 0. You change the LED 0 equal to 0 at the else part. No, yeah. Okay, now you compile again. Okay, thrice b equal to 0v. Okay, you count how many zero you have, the thrice b.
7.
7 0. Okay, okay.
So is it like last week, my program, our problems?
Same problem.
I guess I'm not sure.
Okay, okay, it's okay. You scroll up a bit. Let me see the declaration. Okay, okay, wait. H include xc dot h define s w 0 r 0. Okay, you control all, then you delete everything. You control all, then you delete everything. Okay, I give you my codes. Okay, in the chat box, I share the code link. Okay, you click code share.io. Okay. In the chat room, in our chat box.
Yeah.
You click into code share, then in the code share you control all, copy, control C, control all, then control C. Okay, then you put into your, yeah. Okay, now you compile again. Okay, I think during your project creation, right? There is no X. You didn't. I'm not sure if you have include XC8 in your compiler, but in your project tree, I see XC8 lah. So okay. So now you go to file. Go to file. Okay, you close all project. Close all projects. Down. No, not open. Close all projects. File. Going down, you see close all project, right? Close all project. Okay, you close all project. Okay, so now you go to new project again. Let me see the config. Okay, new project. Okay, standalone project. Click standalone project. Okay, next. Okay, 16F. 16F877A. Okay, next. Okay, XC8. Okay, next. Okay, then you click W3. Okay, click W3. Week 3. You okay, whatever. Okay, next. Finish. Okay, then in your source file, you right click, add new file. Source file. Okay, made in OC, yeah, correct. Okay, yeah, give it a name. Okay. Okay, finish. Okay, then you control all, then delete. Okay, then go to the code. Okay, now you compile again. Okay, build successful. So I think that the error was caused by during project creation, right? Maybe the compiler is not selected.
No, sir. I tried before this. I tried to create, but all the ways the same. I don't know what's the problem.
Okay, okay. So now you remember the step, right?
Yeah.
Okay, so you make sure you try a few times. Maybe some errors that I couldn't see just now that you have done in your previous project.
Okay.
Yeah.
Okay, thank you. Sorry, sir.
It's okay, it's okay. Others okay? If okay, then I go to the next. Okay, Kaseng, you let me present. You stop present. Okay, for others, if you want to get the codes, you can go to the link that I shared just now. Okay, but try not to do amendment, okay, because we are sharing the same platform. Okay, we are sharing the same okay, so you copy all, then you select all, then copy out. Okay, don't cut. Okay, if you cut, the codes will be gone here because we are sharing the same source here. Okay, then next is okay, next is our active low configuration. Okay, we have to look at the wiring again. Okay, for active low configuration, okay, when the button is pressed, the status of the pin will be low. Just now, active high, right? When the button is pressed, the status of the pin is high. High here means 1, that means got current flow in. Okay, when current flow in, the status is equal to high. Whereas for active low configuration, when the button is pressed, okay, the port will be equal to 0. The port will be equal to 0. So how the current flow? You look at the diagram. So when the button is not pressed, you see the power supply is always connected to the port, to the pin. Okay, when the button is not pressed, the power supply is always go in. So RB, this part, let's say RB1, I take RB1 example, you can put whatever. Okay, you can put you can try RD or RE or whatever. Okay, I use RB1. Okay, when the button is not pressed, the current always flow into RB1. So RB1 is always equal to 1. RB1 is always high until the button is pressed, right? Until the button is pressed, you see the current, it can go two way. It is either going to ground, or it is either going to the port. But the current tends to flow to easier path, which is it has less resistance or impedance. Okay, so when this button is pressed, right, the current will not going in here because at the input port, it is always high impedance or high resistance. So the current will not coming in here. Instead, the current will flow to the ground. So when the current flow into the ground, okay, that means the current is not go into RB1. So RB1 will be equal to 0. RB1 will be equal to low. So I repeat again. When button is not pressed, current always go into the port. Okay, so the port is always high. Okay, the port here, I take RB1 as example. Okay, so RB1 is always high. So in my program, if I put RB1 is equal to high, right? I know that the button is not pressed. Okay, so when the microcontroller knowing that, okay, when the microcontroller will know that the button is pressed is when RB1 equal to low, is when RB1 equal to 0. I know that the button is pressed. Okay, so this is active low configuration. Okay, look at the program. Okay, so I have another input. Okay, I have another, so H define, okay, SW1, okay, switch 1 as RB1. Okay, okay, then I have to change my trice B setting because now not only port B RB0 is input, but RB1 is also input. So I have two inputs here. So thrice B setting should be 60 and 21. Okay, so the explanation notes is make pin 0 and pin 1, which is RB0 and RB1, to be digital input pins. Okay, to be digital input pins. All other pins will be digital output. Okay, that is from RB2 until RB7 will be all digital outputs. Okay, then I write a new if statement if switch 1 is pressed. Okay, if switch 1 is pressed, then LED 1 is I'm using LED 1 or what? I haven't declared, sorry. So hash define LED 1 to RB6. Okay, I use RB6 as LED 1. Okay, so now if switch 1 is pressed, LED 1 equal to 1, turn on. Okay, semicolon. Else, if it is not pressed, LED 1 equal to off. Okay, so now I add some descriptions. Turn on LED 0, turn on LED 1. So again, because switch 1 is active low configuration, okay, how the microcontroller how the microcontroller will know that the switch is being pressed? It is when the signal of RB1 becomes 0, right? When it is low, right? Okay, this is called active low configuration. Okay, the hardware side is active low. So just now LED 0 is active. Okay, just now the switch 0 is active high configuration. Okay, so when switch 1 is equal to 0, I know that switch 1 is being pressed. Okay, let's look at the wiring again. When the switch is pressed, right, no current will flow into RB1. The current will flow to the ground. When current flow to the ground, RB1 status will be equal to low, will be equal to 0. So if RB1 is equal to low, right, is equal to 0, I know that switch 1 is being pressed. Okay? Okay, I get your feedback first. So far, okay? Everyone okay with this?
Yes, sir.
Okay, then I copy the code. Okay, in case you cannot type, okay? So I share the code in the same link, so you can get the codes there. Okay, you can get the codes there in case you didn't manage to copy. Okay. Okay, so now, okay, let's compile. After you have done, then we compile. Okay, build successful. Then go to my real fix simulator. Okay, remember to add a push button. So remember to set the pin to be port B pin 1. Okay, port B pin 1. Okay, so now you look at the screen here, because you need to make it active low. Okay, so you go to pin select, choose port B pin 1, then go to type, right? Okay, make sure it is when pressed it is equal to 0. When not pressed, which is when normal is equal to 1. Okay, make sure it is active low configuration. Active low configuration here means when pressed, right, if you give you signal of 0. When pressed, it will give you signal of 0. Okay, then if done, then you try to run, load the hex file. Okay, once you load the hex file, then you run, then you try. Okay, so I get my LED at port B6 turn on. Okay, whenever I press on push button of RB1. Okay, means the program is okay. Okay, everything is fine here. Okay, so far at your side, okay?
Sir, can you show the output again?
Output the real big simulator?
Yes, sir.
Okay. You want me to press the button?
Yeah.
Okay, so when I press on RB1 push button, RB6 LED turn on.
Right.
Okay, when I press on RB0 push button, okay, LED B7 turn on. Okay.
My one port B7 is always on.
Yeah,
Your port
yeah,
B7 always on means what?
Means
Without
without pressing, then will turn it. Will be lighting up.
even though you did not press on RB0, right?
Yeah.
How about you press RB0?
When I press RB0, it will just turn off the light.
Off. Because your RB0, right?
Yeah.
You did not choose
type.
press when press is equal to 1, you did not make it active high configuration.
Press is press is equal to 1. Okay.
Press is 1, okay?
Oh.
RB0 press is 1.
Okay.
If you look at the code, when it is equal to 1, I know that it is pressed. You see what I wrote here? SW0 is pressed. Then the status is it has to be equal to 1, then only it can execute LED 0.
Oh, okay.
Okay, so this is so the key of today's lesson is active high and active low for input. Okay, you see 1 is equal to 1, 1 is equal to 0.
Okay, sir. Thank you, sir.
Okay. Okay, so now if you are okay with this, another thing I want to inform you, I want to show you before we go further is actually if you want to make your program very simple, this 4 line of define, right, you can delete. Okay, if you don't like to use symbol, if you don't like to declare, your own variables such as SW0, if you don't like to use LED 0, if you don't like to use SW1, you can delete. No problem. Okay, for example, I take example only. I delete. Okay, means I comment. Define SW0, okay, to RB0. Okay, I define. Okay, I remove the definition. Okay, the declaration of SW0. Okay, so in my program I cannot use SW0 already, right? Because SW0 is an unknown now because I have deleted the declaration. So in my while here, I can put RB0 is equal to 1. Okay, same thing. If I don't like to use LED, right? I don't like to use LED as my symbol. LED 0, I can remove the declaration part. I can remove the declaration part. So once I remove the declaration part, right? In my program, my compiler will no longer able to identify what is LED 0. Since LED 0 is an unknown, see, it has changed from blue color to black color. Okay, so it's an unknown now. So I know that it is my RB7. Okay, I know that it is my RB7. Because why? Because RB7 is connected to the LED, right? Then I know that I want to control this thing. Okay. Actually, in your program, you can do this. Okay, no wrong. You see, when I compile, right, I can use RB0, RB7 in my programming. You see, build successful. Even if I then load my hex file here, when I run, right, okay, I can still control RB0 and LED B7. Okay, so then since we can use RB0, RB7, all these pin number to do the programming, then why we still need to define a variable to represent those pin? Can you tell me why? Okay, my question is simple. Since I can directly use RB0, RB7, or whatever in my programming, then why we still need to do the declaration? Why we still need to use SW0 or LED0, or why we still need to create a name for this pin, for all this pin? Why not straight away use RB0, RB7, all this? Then our program will be a lot simpler, right? Okay, we don't have to do the declaration. Okay, can you tell me why? Since we can use RB0, RB7, okay, we know that RB0 is our switch. We know that RB7 is our LED. Then we can straight away use the pin number in our programming lah. Then why we still need to declare to give it a name as SW0, LED0? Why?
Easy reference.
Yeah, it's for easy reference. Okay, because otherwise, if one or two LEDs, if your project you have only one or two input outputs, then no problem. You don't want to declare also can, because you know what, I have one LED, one output only, and then I have one push button, one input only. So you know that this input must be the push button, this output must be my LED. But if you have a lot, hundreds, okay, or more than 10 is considered a lot already, okay, then very difficult to read. You can forget your RB0 is what already. It's sensor 1 or sensor 2. It's a smoke sensor or it's a light sensor or what. Okay, very difficult to read, right? So that's why this define is very useful, okay? So that we can use our sensor name or our input name, okay, any names that we declare here to represent the pin. So it will make our programming easier to read. Okay, for example, I simply change. For example, this is my smoke sensor. Okay, my smoke sensor. Okay, this is my smoke sensor. Okay, smoke sensor I connect to RB0. Okay, then you see it's very easy to read. Okay, this is my smoke sensor. Okay, so I know that when RB0 will the smoke sensor will be connected to RB0. Okay, so then I know that when smoke sensor triggers something, then I turn on my LED, which is my alarm light. Okay, you will, red alarm light will be turned on, for example. Okay, so in the declaration part is actually make our program easier to read. Okay, so make good use of the define, make good use of the declaration. Okay, then I have introduced you what is active high and what is active low configuration. Okay, so next thing I want to show you is current sinking and current sourcing output. Okay, let's look back the configuration again. Okay, active high, active low done, then we go to digital output. So for digital output, if you scroll back to this page, for digital input, two types of wiring. Digital output, we also have two types of wiring, which is current sourcing and current sinking. Okay, we are first looking at the current sourcing part. So for the current sourcing part, the LED will be connected, one side of the LED will be connected to ground, another side of the LED will be connected to our microcontroller through a protection resistor. Okay, this is to prevent overcurrent. Okay, so now if you don't put overcurrent resistor also can. Okay, the connection is very simple. One side to LED, another side of the LED to ground, another side of the LED. Okay, one side of LED to ground, another side of LED to microcontroller. Okay, you can still get the LED turned on. Okay, it's just that the resistor is for protection purpose. Okay, so it is called current sourcing, because the microcontroller is where the current will be is where the current will be coming from. Okay, the microcontroller is where the current will be providing the current. That's why it is the source of the current. Okay, sorry, I repeat again. It is called current sourcing because the microcontroller will provide current to the LED. Okay, so when the logic at the port here is equal to 1, the current will flow out. Okay, so when the logic is equal to 1, the current will flow out, then it will turn on the LED. Okay, so I go back to my programming. Both my LED 0 and LED 1 are current sourcing mode. Current sourcing. Okay, both my LED 0 and LED 1 are current sourcing. You see, when equal to 1, when equal to 1, it is turned on. Okay, I will turn on the LED. Okay, now I want to try another one, which is current sinking. Okay, I want to try current sinking. So I define define XW2 to RB2, then hash define LED2 to RB5. Okay, so my tries B here, I have 3 inputs. Okay, so I need to put 3 times of 1. Okay, RB0, RB1, RB2 as input 1, 1, 1. Okay, so RB0, RB1, and RB2 are now all digital inputs. So RB3 to RB7 are digital outputs. Okay, then write a program. If SW2 is equal to 0. Okay, I use active low configuration. Okay, I use active low configuration. Active low configuration. Okay, then my LED 2 will be equal to 0. Okay, so this is current sinking. Current sinking mode. 0 turn on. Okay, 0 is equal to turning on. Okay, else LED 2 will be equal to 1. 1 means off. Okay, so compile. Everything is looking good. So I control the code and put at code share. Okay, so you can get the codes at code share. Okay, then I go back to my summary notes there. Okay, so you see current sinking. Current sinking, one side. Okay, I'm a bit chong hey. I repeat again. All the times I always repeat what I have taught. Okay, you see LED. For current sourcing, one side of the LED is go to ground. Okay, then the positive side of the LED going to the microcontroller. Okay, microcontroller is the current provider. That's why called sourcing. Okay, for sinking, right? Okay, one side of the LED is not this side of LED, right? This time, LED is not going to ground, but the LED is going to power supply. Okay, then another side of the LED is going to port. So the current is flowing from outside to the microcontroller. That's why it is called sinking. It's just like water sink. Okay, the water is flowing in. Okay, it's called sinking because the current is flowing in. Okay, so to allow a complete circuit, to make the current able to sinking in, right? Okay, your port logic has to be low, has to be 0. When it is equal to 0, again that means the current is open its port for the current to flow in. When it allows the current to flow in, right, means when the gate is open here, then you will see the LED turn on. Okay, then you will see a LED turn on. That means to turn on this LED, your RB 6, 7, 5. Okay, your RB5 has to be 0. to turn on the LED, your RB5 has to be 0. When your RB5 is 0, you have a complete circuit. When you have a complete circuit, the current is able to flowing into the microcontroller. When you have a complete circuit, you see your LED turning on. Okay? Okay, so here my LED 2, which is RB5, when it's equal to 0, that means I allow the LED, I allow the current to flow through LED going to microcontroller, then I will get the microcontroller turned on. As simple as this. Then now, RB5 is my current syncing LED, right? So you need to make it syncing. So you need to choose active on 0. By default, it is active on 1, right? So now we change to active on 0. Okay, active on 0, then remember to pull in a push button, okay, and make it RB012, make it RB2. Okay, then remember to make it, to choose it as an active low. That means when press is equal to 0, normal equal to 1. Okay, then load the new hex file. Okay, then run. Okay, so now when I press RB2, I see my RB5 turning on. When I press my RB1, I see my RB6 turn on. When I press my RB0, I see my RB7 turn on. Okay, so that is current syncing mode of LED. So usually I will prefer to use current syncing, okay, in my project. Okay, you will find your microcontroller is is not so hot, okay, to use current syncing, okay, because it is not the power provider. Okay, if 1 or 2 LEDs or 1 or 2 outputs are okay. If you have a lot, right, you will find that if you use current sourcing, your LED tends to get hot easily, okay, because it will provide power supply. Okay, so it will get a little hot. Okay, if you use current sourcing. So usually I will use current syncing mode. So current syncing mode, to turn on the LED, my logic is equal to 0. When equal to 0, you will get a complete circuit. So you will let the current to flow in, then turn on the LED. Okay, so that is current syncing. Okay, so I have okay, about 1 hour. Okay, we have finished this introduction. I mean revision of current syncing, current sourcing, active high, active low. This was supposed to, we have to do it last week. Okay. Okay, so far okay. Then I want to go into lab 1. Before I go to lab 1, I need to show you another thing. Okay, just now, do you understand what is port B now? Trice B is, again, Trice B is for us to setting input output, right? Port B is actually for us to turn on or turn off the pins only. Port B is for us to turn on or turn off. But because of bit 0, bit 1, and bit 2 are inputs, right? So port B have no control. So this one, you put 1 or 0, it doesn't matter, because port B0, B1, and B2, the status of 1 or 0, right, will be determined by the devices that we connect, will be determined by the push button that we connect. So your port B cannot turn the sensor on or turn the sensor off, okay, because it will be overwritten by the smoke sensor that I have here, for example. It will be overwritten by switch 1. So for inputs, right, the port B has no control. Even yes, right, it will be overwritten very fast after it fall into the while 1 loop. Okay, so in this case, before the program go into while 1, right, so this port B, when I set RB3 until RB7 as 1, right, that means at the very beginning, when the microcontroller run until this line, my digital output 3, RB3 until digital output RB7, these 5 outputs will be turned on. these 5 outputs will be turned on. Then whether continue turn on or turn off, right? It depends on the logic of your codes. It depends on the logics of your codes. If the logics of your codes is to turn it off, right? Then you will never see these 5 ports turn on. But it did turn on. It did turn on for very short interval until it has no enough time to get the LED to emit light. So you will never see it turn on, but it did for a very short interval only. So what I want to tell you here is tries B, right? Or tries C or tries D is for us to set input or output. For port B, right, is for us to set on or off, as simple as this. Okay, if you don't like to use RB0 like this, right, you can write something like this. You can write RB7 equal to 1, RB5, RB6 equal to 1, RB5 equal to 1. Okay, it's the same thing. It's the same thing as you turn on these 3 pins. So instead of write 3 lines of codes, right, you write 1 line only to represent these 3 or 4 lines or 5 lines. Okay, so I repeat again, the purpose I show you port B here, right, is to tell you that I can turn on or turn off a particular pin, right, by writing a line of code. For example, I'm turning on these 5 outputs, okay, or okay, using port B, okay, whereas for tries B is for us to set input or output only. So far, okay, port is for to turn on or off. Tries is for set input or output. So far, okay? Everyone?
Yes, sir.
Okay, then maybe you will ask me, then what is the purpose to use port B? Okay, port B usually we don't turn, we are not turning on. Usually for port B, right, it's for setting of all 0. Okay, it's for initialization. Initialization means